When it was first presented, the sixth-generation fighter idea had unique distinguishing traits. With time, the well-defined notion has become vague and hard to grasp. The basic idea was inspired from developments in traditional combat aircraft technology, materials, electronics, and engines. Rapid breakthroughs in software algorithms for machine learning and AI-based decision-making were not sufficiently considered into the idea. The goalposts laying down how sixth-gen fighters must score regularly change. Optional manning. Optional manning would allow the aircraft to undertake missions in highly disputed airspace without risk of loss of life. Missions like as suppression of enemy air defenses, SEAD, and strikes on high-value surface targets pose substantial risks even for stealth jets, since low observability, LO, is never total. Broad-spectrum stealth. Unlike fifth-gen fighters, which are solely undetectable to centimetric wave radars, sixth-gen aircraft would be invisible even to metric and decimetric wave radars, such as Russia's Nebo-M. Next-generation engines. Next-generation turbine-based power plants will offer expanded electrical power generating capacity to power sensors, communication systems, directed energy weapons, actuation systems, accessories, and avionics. Directed energy weapons. Next-generation fighters will have strong lasers to burn the seeker of air defense, AD, or air-to-air missiles. Conceivably, they may be strong enough to attack vulnerable ground targets. Unified Electronic Warfare System. A Unified Electronic Warfare System, UEWS, will act as radar, electronic warfare, data transfer, and communications equipment. It will also operate as a navigation system and IFF transponder. Scope creep. Even while technology was evolving for the sixth-gen idea, more capabilities were added to the design due of rapid technological breakthroughs, including drones. These included control center operations, in-flight software updates, radiophotonic radar, and multispectral optical system. Control center operations. Next-gen fighters would be able to operate as a command center for drones, including attack drones, when executing combined operations. In-flight software updates. The capability will allow updates of software that controls the hardware. Advances in software design now permit upgrades that don't interfere with fighters' ability to fly. You may correct software defects or unlock new capabilities while a fighter is on a mission. Radiophotonic radar. They employ pulsing lasers instead of radio crystals to create and analyze near-perfect sine wave transmissions and reflections. As a result, they may employ smaller antennas to transmit wideband UHF signals that resist RF LO shaping. The returning signal may be processed to an extent where it provides a 3D image of the object, not unlike an optical image. Multispectral optical system. Multispectral optical systems working in multiple ranges, the laser, infrared, ultraviolet, and optical band, will augment the radiophotonic radar. Computing and AI advances. Meanwhile, increase in onboard computer capabilities, governed by Moore's Law, and advances in artificial intelligence opened up the possibility of outsourcing many of the abilities of a sixth-gen fighter to inexpensive, actionable drones either directly controlled by the sixth-generation fighter or controlled through a larger behind-the-scenes mothership aircraft. The U.S. is researching the notion of a sixth-gen fighter working alongside drones utilizing a system of systems strategy currently referred to as Next-Generation Air Dominance, NGAD, NGAD. Next-Generation Air Dominance, NGAD, NGAD. The Next-Generation Air Dominance, NGAD, proposes deploying a family of systems, HUF-OS, focused around a new sixth-generation fighter aircraft, to be fielded in the 2030s. The FX, or Penetrating Counter-Air, PCA, in the case of the USAF, and the FAAXX in the case of the USN. No one is fully sure what capabilities will be kept in the sixth-generation fighter and those outsourced to supporting specialist drones, now referred to as CTA. Collaborative Combat Aircraft, CCA. CCA. The PCA concept is prompted by the necessity to couple a pilot with drones effortlessly. Current generation drones function as eyes and ears, or as guided missiles. They have to be piloted from the ground. Because of their autonomy, CTAs may execute directives supplied by a pilot exactly as a formation pilot executes directions given by the formation lead. CCAs will give capabilities like as magazine depth, weapon truck, battle space monitoring, and communication relay. In surveillance duties, the CCAs will not simply send their sensor data and overwhelm man-in-the-loop operators. They will employ AI to communicate evaluations, and, if required, take action on their own initiative or in coordination with the rest of the force. Program status. The capabilities of the 6th Gen fighter that will be a member of the NGAD have still to be firmed up. The U.S. Defense Department has yet to decide if the essential technologies employed in the NGAD fighter aircraft were mature enough to enable entry into the engineering and manufacturing development (EMD) phase of the NGAD program's acquisition timetable. CCAs are much more far into the future. The issues include maximizing usefulness, while keeping attritability and integrating them into operational units. It's noteworthy to note that the NGAD idea is not bound to a 6th generation fighter. 5th and even 4.5 generation fighters might be modified to NGAD.